Hello everyone. Welcome to my YouTube channel. In this video we will talk about the second part of lunar rock samples that have been brought by Apollo 11 mission or the Apollo team for scientific studies. Disclaimer: this video is for educational purposes only. Any information, especially lunar rock details and images, are taken from the article posted online. Welcome to the second part of our discussion on the Apollo 11 lunar rock samples. In this part, we will delve deeper into the scientific significance of these samples and the groundbreaking discoveries that have been made, thanks to the analysis of these precious rocks. Join us as we uncover the secrets of the moon and learn more about the incredible rock sample that was brought by the Apollo 11 lunar mission team. Let's continue our exploration of the wonders of the universe together. Since it's just the continuation of the previous topic, let's jump into it. Let's start from 10,056 Regolith Breccia. Sample 10,056 is an unusual regolith breccia compared to others that were collected during the Apollo 11 mission to the moon, consisting of rock and mineral clasts in a fused agglutinate-rich matrix. Agglutinates are small glassy breccias formed when a micrometeorite, a millimeter or less in size, strikes the lunar regolith. Millions of micrometeorites strike the moon every day. When a micrometeorite strikes the lunar surface, some of the impacted regolith melts, but not completely, so the product is a glass with mineral and rock fragments entrained. Type: igneous, rock-forming mineral. Plagioclase feldspar pyroxene. Accessory minerals: ilmenite, troilite, metallic iron, glass. 10,057 Vesicular ilmenite basalt. 10,057 is a fine-grained vesicular ilmenite basalt, weight 919 grams, that is 3.6 billion years old. It has a granular texture consisting of interlocking crystals of pyroxene, plagioclase feldspar and ilmenite. It is thought to be from one of two basalt flows sampled by the Apollo 11 astronauts and is characterized by its relatively high potassium content. Modally, 10% of the sample is void, now seen as vesicles, indicating that the basaltic magma originally had a high gas content. Cristobalite and AK-rich glass have been recorded filling interstitial spaces within the sample. Other minerals present in small amounts include phosphate, troilite and iron metal. The larger pyroxene crystals have compositions that vary from pigeonite, low Ca, coarse to augite, high Ca, rims. Type: igneous, rock-forming mineral. Plagioclase feldspar pyroxene ilmenite pigeonite augite. Accessory minerals: troilite, cristobalite, glass. 10,058 Coarse-grained ilmenite basalt. 10,058 is a coarse-grained ilmenite basalt, weight 282 grams, that is 3.7 billion years old. It has also been described as a medium-grained, buggy, ophitic, cristobalite basalt. The cristobalite is relatively abundant, modally 5%, and has a distinctive cracking pattern due to inversion of high to low cristobalite structure. Rotation 1 shows an example of cristobalite wrapping around ilmenite. Other crystals have lath-like form or appear interstitially. Cristobalite has the same birefringence as plagioclase feldspar, so is not at first easy to see. Major constituents in the rock are pyroxene, plagioclase feldspar and ilmenite, modally around 94% in total. Accessory amounts of apatite, troilite, and AYZR mineral, probably tranquility ITE, plus a trace of glass are also reported. Pyroxene compositions vary with increasing iron content from augite towards the rare lunar species pyroxferrolite. Type: igneous, rock-forming mineral. Plagioclase feldspar pyroxene ilmenite. Accessory minerals: apatite, troilite, tranquility ITE, cristobalite, glass. 10,059 Regolith Breccia. Sample 10,059 is a coherent glass matrix regolith breccia, with a composition that matches the local soil. Detailed investigations reveal that 10,059 contains mare basalt fragments, lunar highland fragments, regolith breccia, agglutinates, clasts of pyroxene, olivine, plagioclase feldspar, ilmenite, orange glass and other glass, all cemented by a dark matrix. Half of the rock is matrix. It contains slightly more orange glass spheres than other Apollo 11 samples. Additionally, in reflected light, small yellow crystals of troilite and silvery metallic iron can be seen. Type: metamorphic, rock-forming mineral. Glass, plagioclase feldspar pyroxene. Accessory minerals: ilmenite, troilite, metallic iron. 10,060 Regolith Breccia. Sample 10060 is one of the largest and best-studied lunar breccias. A high percentage of it is derived from soil at the Apollo 11 landing site. One side of the sample is covered with glass-lined micrometeorite pits. It is porous, indicating it was gas-rich, with micron-sized intergranular voids that can best be seen in reflected light or using a scanning electron microscope. It has an abundance of glass of various types and stages of devitrification. In thin section, basaltic fragments are the predominant clast type in 10060. One of the largest basaltic clasts, termed a vitrifier, contains well-formed pyroxene phenocrysts, olivine, bladed ilmenite, and small amounts of bladed armalcolite set in a ground mass of basaltic glass with feathery pyroxene. Gabbroic anorthosite clasts have also been recorded in this sample. The large armalcolite grains appear to have reacted with the melt, forming ilmenite at the rims. Type: igneous, rock-forming mineral, plagioclase feldspar pyroxene. Accessory minerals: ilmenite, troilite, metallic iron. 10061 Regolith Breccia. 10061 is a friable regolith breccia with components similar to the soil at the Apollo 11 site. It has abundant basalt fragments, mineral fragments, glass fragments and round beads, and a considerable fine-grained dark matrix. Type: metamorphic, rock-forming mineral, pyroxene, plagioclase feldspar. Accessory minerals: ilmenite, troilite, metallic iron, glass. 10062 Ilmenite basalt. Sample 10062 is a fine-grained vesicular basalt that crystallized 3.8 billion years ago, measured by AR, and as such is one of the oldest lunar mare basalts. Texturally it is a vuggy, subophytic basalt with radiating, lath-like and acicular crystals of plagioclase interground with tabular and skeletal crystals of ilmenite, irregular grains of zoned clinopyroxene and olivine. The pyroxene crystals are chemically zoned, and more remarkable is the zoning of some olivine which appear to display sector zoning. Late-stage cristobalite, phyolite, ulvospinel, troilite and apatite are also reported from the Mesosaxis. Armalcolite is present as dull gray rounded grains forming inclusions in ilmenite. It has been suggested that 10062 is related to other lunar basalts such as 10003 and 10029. Type: igneous, rock-forming mineral, pyroxene, plagioclase feldspar, ilmenite. Accessory minerals: cristobalite, phyolite, ulvospinel, apatite, armalcolite, troilite, metallic iron. 10063 22 Regolith Breccia. 10063 is a typical Apollo 11 regolith breccia and contains large basalt clasts, mineral clasts and a range of yellowish and orange glass fragments. A small percentage of agglutinate is also reported. Rotation 1 shows an orange glass bead, a shocked pyroxene crystal, a basaltic clast and a feldspar-rich anorthositic clast. Rotation 2 shows part of a large basaltic clast. The sample weighed 148 grams before analysis and has not been dated. Type: metamorphic, rock-forming mineral, pyroxene, plagioclase feldspar, glass. Accessory minerals: olivine, ilmenite, troilite, metallic iron. 10064 Regolith Breccia. Sample 10064 is a typical Apollo 11 regolith breccia. Made up of components found in the local soil. Detailed investigations reveal that 10064 contains mare basalt fragments, lunar highland fragments, regolith breccia, agglutinates, clasts of pyroxene, olivine, plagioclase feldspar, ilmenite, orange glass and other glass, all cemented by a dark matrix. Half of the rock is matrix. Additionally, in reflected light, small yellow crystals of troilite and silvery metallic iron are visible. Type: metamorphic, rock-forming mineral, glass, pyroxene, plagioclase feldspar, rock fragments. Accessory minerals: olivine, ilmenite, troilite, metallic iron. 10065 Regolith Breccia. Sample 10065 is a moderately coherent regolith breccia. It is welded together with many fine particles of glass, but 18% is pore space. About 24% of the breccia is thought to be from the lunar highlands, plagioclase-rich anorthosites. See Rotation 2. 10065 also contains basalt fragments, agglutinates, mineral clasts and glass, the latter forming irregular fragments and rounded spheres, cemented with a fine-grained dark glassy matrix. The sample is notable for the common subspherical orange glass beads it contains. These have a presumed volcanic origin. The rare species armalcolite is reported from this sample. Type: metamorphic. Rock-forming mineral. Glass pyroxene plagioclase feldspar rock fragments. Accessory minerals: ilmenite, troilite, metallic iron, armalcolite. 10,067 Regolith, Breccia. Sample 10,067 is typical of regolith soil. Breccia is found at the Apollo 11 landing site. It contains basaltic rock fragments, lithic clasts, mineral clasts and colored glass in a dark glassy matrix. Particularly noticeable in thin section are the spherules and fragments of orange glass, which are volcanic in origin, formed in fire fountains during eruption of the lunar mare basalts. In reflected light, relatively quite large grains of troilite and metallic iron can also be seen. Type: metamorphic. Rock-forming mineral. Glass plagioclase feldspar pyroxene ilmenite. Accessory minerals: troilite, metallic iron. 10,068 Regolith, Breccia. 10,068 is a coherent medium-gray regolith breccia, weight 218 grams, with a rounded surface covered in micrometeorite pits. It has a glassy matrix in which are found a high proportion of basalt fragments, together with lower abundances of lunar highland rocks, mineral fragments, glass-welded aggregates, agglutinic, and a range of different types of glass fragments. The heterogeneous nature of the sample can perhaps be seen by examining the reflected light view, where the textures of different rock clasts is particularly obvious. Type: metamorphic. Rock-forming mineral. Glass plagioclase feldspar pyroxene. Accessory minerals: ilmenite, troilite, metallic iron. 10,069 Fine-grained ilmenite basalt. Sample 10,069 is a fine-grained buggy basalt that crystallized 3.68 billion years ago, measured by RBSR. Texturally it is a fine-grained, buggy to vesicular, granular basalt, although in places the grain size varies. Vesicles are up to 1.5 mm across. Plagioclase feldspar, olivine, pyroxene and ilmenite are the four main constituents. The pyroxene crystals are chemically zoned. Additionally, cristobalite, phosphate and glass are present, but in low abundance. In reflected light, the iron sulfide troilite can be seen as small pale yellow crystals. Type: igneous. Rock-forming mineral. Plagioclase feldspar pyroxene ilmenite. Accessory minerals: troilite, metallic iron. 10,070 Regolith, Breccia. Sample 10,070 is a typical Apollo 11 regolith breccia, similar in composition to Apollo 11 soil. Detailed investigations reveal that 10,070 contains mare basalt fragments, lunar highland fragments, anorthosite, regolith breccia, agglutinates, clasts of pyroxene, olivine, plagioclase feldspar, ilmenite, orange glass and other glass, all cemented by a dark matrix. 60% of the rock is matrix. A few grains of troilite, yellow, and metallic iron, silvery gray, are visible in reflected light. Type: metamorphic. Rock-forming mineral. Glass pyroxene plagioclase feldspar ilmenite. Accessory minerals: troilite, metallic iron. 10,071 High T basalt. 10,071 is a high T basalt with up to 15% ilmenite, weight 190 grams, and two distinct lithologies. It is 3.68 billion years old. The sample contains armalcolite, a rare MgT oxide species named in honor of the three Apollo 11 astronauts, Neil Armstrong, Buzz Aldrin and Michael Collins. This mineral was first discovered in Apollo 11 samples, but has since been found elsewhere on the Moon and in lamproite dikes here on Earth. The sample is notable for its zoned pyroxene, augite, pigeonite, and small but significant olivine content, with crossed polars XPL. Many of the olivine crystals appear blue. The accessory mineral assemblage includes troilite, phosphate and cristobalite. Type: igneous. Rock-forming mineral. Plagioclase feldspar pyroxene ilmenite pigeonite augite. Accessory minerals: apatite, troilite, cristobalite, armalcolite, olivine. 10,072 Vesicular basalt. Sample 10,072 is a fine-grained vesicular basalt that crystallized 3.6 billion years ago, measured by AR, RBSR and SM, and methods. Its texture is best described as subophytic and intercertal. Plagioclase feldspar, pyroxene and ilmenite are the three main constituents. The chemically zoned pyroxene crystals contain rare rod-shaped inclusions of tranquility ite. A second lunar species, armalcolite, is also reported from this sample. Additionally, olivine, cristobalite and glass are present, but in low abundance, the latter two forming in interstitial patches. In reflected light, the iron sulfide troilite can be seen as small pale yellow crystals, occasionally associated with metallic iron. Type: igneous, rock-forming mineral. Plagioclase feldspar pyroxene ilmenite. Accessory minerals: olivine armalcolite troilite metallic iron glass. 10,073 Regolith Breccia. Sample 10,073 is a friable, porous fragmental soil breccia, rather typically of the Apollo 11 landing site. The majority of the rock fragments are basalt, but about 25% are lunar highland material, plagioclase-rich anorthosites. 10,073 also contains agglutinates, mineral clasts and glass, the latter forming irregular fragments and rounded spheres, cemented with a fine-grained dark matrix. Our sample contains one large, 5 mm long, fragment of basalt and a few smaller fragments, largest around 1 mm across, of anorthosite. Surrounding the sample are flowery growths, contamination, that have developed since the thin section was prepared. Type: metamorphic, rock-forming mineral. Glass plagioclase feldspar pyroxene. Accessory minerals: ilmenite troilite metallic iron. 10,074 Regolith Breccia. Sample 10,074 is a coherent glass matrix regolith breccia containing abundant lithic clasts of lunar basalt. 10,074 also contains lunar highland fragments, agglutinates, mineral clasts and glass, the latter forming irregular fragments and rounded spheres, cemented with a fine-grained dark matrix, 51%. Some fragments are partially mantled by a rim of vesiculated brown glass. In reflected light, small yellow crystals of troilite and silvery metallic iron are visible. The sample is similar to 10,084. Type: metamorphic, rock-forming mineral. Glass pyroxene plagioclase feldspar. Accessory minerals: ilmenite troilite metallic iron. 10,075-20 Regolith Breccia. 10,075 is a typical Apollo 11 regolith breccia, made up of typical components of the Apollo 11 soil. It is a subangular, medium gray, partly devitrified fine breccia. Rotation 1 shows an orange glass bead, a shocked pyroxene crystal, a basaltic clast, and a feldspar-rich anorthositic clast. Rotation 2 shows part of a large basaltic clast. Rotation 2 shows a basaltic clast and a crystallite-rich, possibly impact melt clast. The sample weighed 53 grams before analysis and has not been dated. Type: metamorphic, rock-forming mineral. Pyroxene plagioclase feldspar glass. Accessory minerals: olivine ilmenite troilite metallic iron. 10,082 Regolith Breccia. Sample 10,082 is a typical regolith breccia made up out of components found in the Apollo 11 soil. Detailed investigations reveal that 10,082 contains Mare basalt fragments, lunar highland fragments, anorthosite, regolith breccia, agglutinates, clasts of pyroxene, olivine, plagioclase feldspar, ilmenite, orange glass and other glass, all cemented by a dark matrix. Over half of the rock is matrix. A few grains of troilite, yellow, and metallic iron, silvery gray, are visible in reflected light. Type: metamorphic, rock-forming mineral. Glass pyroxene plagioclase feldspar. Accessory minerals: olivine ilmenite troilite metallic iron. 10,085 Coarse-grained basalt. Sample 10,085 contains the coarse fines, greater than 1 mm, that remained after sieving a portion of regolith sample 10,002. Approximately 250 thin sections were made from 10,085 and these were widely distributed during the early allocations of lunar samples. The first anorthosites were found in this sample, however our sample is almost entirely lunar basalt. Other investigators have estimated that 37% of sample 10,085 is basalt. The remainder is soil breccia, 52%, glass, 4%, anorthosite, 2%, anorthosite glass, 1.5%, and anorthosite breccia, 1.5%. Our sample mainly contains plagioclase feldspar, pyroxene and ilmenite opaque crystals, with minor amounts of cristobalite and troilite also present, the latter visible as small yellowish crystals in reflected light. Note that the sample is slightly thick, so plagioclase feldspar shows yellowish colors in transmitted light instead of the normal shades of gray. Type: igneous, Rock-forming mineral. Plagioclase feldspar pyroxene ilmenite. Accessory minerals. Cristobalite troilite metallic iron. 10,092 coarse-grained basalt. Sample 10,092 is a fine-grained vesicular basalt that has not been dated. Plagioclase feldspar, pyroxene and ilmenite are the three main constituents. The pyroxene crystals are chemically zoned and display strain features that are visible between crossed polars. Additionally, olivine, silica cristobalite, ulvospinel, chrome spinel, phosphate and AK-rich glass are present, but in low abundance. In reflected light, the iron sulfide troilite can be seen as small pale yellow crystals, some hosting minute inclusions of metallic iron. Type: igneous, rock-forming mineral. Plagioclase feldspar pyroxene ilmenite. Accessory minerals. Troilite metallic iron. 10,093 Regolith Breccia. Sample 10,093 is a typical Apollo 11 Regolith Breccia. It is relatively coherent, with typical dark glass matrix and sparse lithic clasts. It has micrometeorite, ZAP, pits on the surface. Detailed investigations reveal that 10,093 contains mare basalt fragments, lunar highland fragments, anorthosite, regolith breccia, agglutinates, clasts of pyroxene, olivine, plagioclase feldspar, ilmenite, orange glass and other glass, all cemented by a dark matrix. Over half of the rock is matrix. A few grains of troilite, yellow, and metallic iron, silvery gray, are visible in reflected light. Type: igneous, rock-forming mineral. Glass pyroxene ilmenite plagioclase feldspar. Accessory minerals. Olivine ilmenite troilite metallic iron. 10,094 Regolith Breccia. Sampa 10,094 is a regolith breccia found close to the Apollo 11 landing site. The outer surface has been pock-marked by micrometeorite impacts. In thin section, 10,094 has a high proportion of fine dark matrix, over 55% of the rock, and an abundance of small clasts of lunar mare basalt. A detailed investigation of its petrography has revealed that it also contains a small lunar highland component, anorthosite, agglutinates, pyroxene, olivine, plagioclase feldspar, ilmenite, orange glass and other glass. Type: metamorphic, rock-forming mineral. Plagioclase feldspar pyroxene. Accessory minerals. Glass ilmenite olivine troilite metallic iron. The analysis of the Apollo 11 lunar rock samples continues to provide fascinating insights into the history of our moon and the solar system. And those are the lunar rock samples that were brought by the Apollo 11 Lunar Mission team. Thanks for watching this video. If you found it informative, don't forget to give it a thumbs up and subscribe to our channel for more debunking videos. Until next time, stay curious and keep exploring. Stay skeptical, stay informed.